So my name is Matt Robinson. I am basically the consortium manager for the Americas for the ROS-Industrial Consortium, based out of Southwest Research Institute in San Antonio, Texas. So I will touch on a few things. I touched a little bit on, notice my title, aligning the goalposts, right? We don't want to move the goalposts, right? We've talked a lot about the objectives. I mean, Maria did a great job talking about what they're trying to do within the ROS-Industrial Consortium here in Asia Pacific are, and you'll hear from Vishnu after I talk, we're all pretty unified, right? But it doesn't mean sometimes the goalposts need aligned, and so that's what I'm talking about today. Relative to where I come from, I'm at Southwest Research Institute. We're a research institute not so different than where we're here today on this campus, but we've been around since 1947, 3,000 folks, 11 technical divisions, doing applied research and development, right? So we get to use a lot of these tools that you've learned about so far while you're here. And we have a team that uses these tools. We kind of eat what we're cooking, if you will, relative to the open source contributions we make and taking advantage of OEM solutions like we heard about with the Melfa driver yesterday in developing advanced robotic solutions. Our robotics group does things from unmanned ground systems, custom robotics, full prototypes working in test environments, and of course weird custom integrations like the observatory pictured here. And we leverage these tools that we've been learning about these past couple days to kind of make these things happen. And then while we do our work, right, we're working hard to make contributions to the ROS-Industrial Open Source Project along the way, and other open source repositories as well. All right, so again, just more examples of the types of systems that we're working on. Maybe the video will play. There it is. Doing a lot in mobility. The one on the bottom left that's actually a video is basically a mobile paint system for airframe airplane parts, right? So what's interesting about that particular application is that, yes, it's scan and plan, which you hear a lot in the context of the work that the Americas does. The scan and plan framework has been, so to speak, an application framework that we've been nurturing for quite a few years now. But the key is that was a different program, and then we changed out the hardware, have it totally doing something in a handful of weeks, right? So that's where we start realizing the value, right? We talked a little bit about tools to enable us to create new applications. Hey, we've got these building blocks, can we do something new relatively quickly? And that's what we're excited about. So, Maria touched on it yesterday. I don't want to belabor it, but right, we talk a lot about developers, robotic engineers, the different kinds of things we're trying to work on, engaging with OEMs who make the industrial hardware, what it is we're trying to do. But we also have a number of other stakeholders too, right? There's the manufacturing engineers that are just trying to make the parts and make sure their processes are running, right? So who are we serving here, right? What is it we're trying to do? And we can't forget about the people who use the systems. We're talking a lot about, we're going to hear a lot about human-robot interaction. We talk a little bit about making things sort of intuitive for end users, the operators. Right? We don't want robotics to be something that we do to people, right? Ideally, these are tools and capabilities that make both operations more efficient and make the job safer and more productive and less stressful for the people that run around in these factories. So one of the big things we do in all of our regions, and we do it as well, is sort of get our memberships together, right? That's what this event is. And we try to get feedback. What is it we're missing? What is it we could be doing better? There's been a recent push in really trying to engage OEMs where they're at. We had a big discussion at ROSCON recently in Europe. Some of you may have heard, where there's a lot of interest in hey, can we make ROS-2 sort of this de facto industrial manipulator framework or a standard? And there's a lot that goes into that, right? So, we have for a number of years been supporting what we call this OEM outreach, right? How do we entice OEMs? What is it that they're trying to offer to their end users, and how can ROS-2 help them please their end users to sell more hardware and solutions into the marketplace? And for the Americas and some of the progress we've made in that front, and that's what we're doing, right? We're trying to educate OEMs, understand where they are at, communicate to them what developers are looking for, because in the end, these are the robotic systems of the future, right? And then provide basically. And then also you'll notice here we talk a little bit about this notion of behavior, right? So there's been a lot of discussion today about interfaces, enabling new capabilities, but in the end, I want a system that behaves, Because again, you start talking about human-robot collaboration, machines and people working in close proximity, there's this notion of trust, right? So if I'm gonna trust this machine that I'm working close to, it needs to have behaviors that I can trust and understand and that are intuitive in the workflow. So those are all some things that we've been actively working on and thinking about. How do we think about these in the context of the solutions we're developing and delivering? Another thing that's come up is we've gotten some issues submitted against the ROS Industrial repos. Like, hey, I don't really understand if ROS Industrial supports ROS-II, right? So we always try to be somewhat explicit. We're obviously doing some work on the website and trying to put more communications together. Obviously, this audience, I think, generally understands that ROS Industrial Open Source Project does support ROS-II. We've really tried to be advocates for people making the jump to ROS-II if they're already legacy ROS-I users, but we could be more explicit, right? But one of the things when it comes to at least how we managed hardware interfaces in ROS-I is a little bit different, right? The industrial OEM, the technology landscape has changed. Robotic OEMs are offering much more performant interfaces than they did back in the early 2000s, right? So our goal, again, at least when it comes to manipulators, is this idea that we leverage OEM-provided external motion interfaces, and they have very capable tools, and just work with them to provide a connectivity or a bridge into the ROS-II ecosystem, right? And that's what we're working on. We're trying to highlight the successes. And you'll notice here, I highlight the great work that's been shared yesterday in the announcement of the Mitsubishi Melfa ROS-II driver, right? We want to highlight these successes and like incentivize others to kind of come along. Hey, you already do good things, just extend it to the ROS-II framework, right? And we can all get better together, right? So again, it's a notion of highlighting OEM solutions. Obviously, I didn't bring the ROS-I version of this chart. If you've ever been out on the ROS Wiki, there is the older ROS-I version of this graphic. But obviously in a ROS-II context, we've had to take a look at how this is a little bit different, right? So long ago, we had some tools. One of them was called I'm blanking on what it was called, Industrial Core. And basically it implemented what we call simple message, which is a protocol that we could actually share information between industrial manipulators and the ROS ecosystem. That sort of has changed in the advent of ROS-II with DDS and this notion of RMW. We're seeing more and more OEM manipulators offer basically ROS-II control, and a couple offer solutions based on micro ROS, and that's fine, right? We enable the OEMs to pick what works for how they build out their solutions and systems, and we can be somewhat flexible as long as we offer a consistent API in enabling those things to be successful in ROS-II application development, right? So we're not trying to like push anybody into something they don't want, ideally, right? We have a big tent. We want everyone to be successful, but then provide more resources to enable OEMs to demystify this ROS-II thing. Right now, it's been an active push that we've been working on in Americas, and I know obviously the team here in AP and my colleagues in Europe as well as they work with the OEMs in their backyards. And that's actually something we've been very excited about. So I wanted to talk about a few actions coming out of the Americas. I mentioned this about this notion of ROS-II as a, so to speak, standard. There's a lot of questions. There was a lot of this notion of, well, what do we mean by interoperability, right? I want to unplug my yellow robot, plug in an orange robot, and it just works, right? That's awesome. Like, I would love to see that too, but we're a long way from there, particularly as you get into more complex motion, right? There's a lot about, again, getting into this notion of behavior, right? So we have a lot of internal discussions to do, and along with our already existing OEM collaboration partners, about what do we mean by interoperability, and what are those layers of interoperability, right? So we are currently having now recurring conversations with a bigger group between ROS-I stakeholders and members of the OSRA community to kind of like sort out where do we want to go here, because it'll probably be multi-step. Talking a little bit about just being able to share some messages, and then getting into this idea about like, hey, how can we start representing detailed motion semantics? But that'll take time. There are a number of different practices, like, hey, let's get them all out there, right? So there's already sort of a, if you will, an Excel spreadsheet being mailed around that lists out all the OEMs, all the manipulators, and like how they support different communications. That's a good place to start, right? Maybe we just start with like, so to speak, a cheat sheet. But like, how do we basically communicate? What are the best ways to interact with these various pieces of hardware? And then codify that somehow. and work together to come up with a way that communicates that's good for everybody. So I guess to circle a bit back also about some of the work we've been doing in the Americas, it's been thinking a little bit more about architecting the solution. I touched a little bit about on scan and plan. You saw the little painting video, and we've been doing finishing for a long time in a number of different ways in how we interact with manipulators. But one of the things that we originally thought of years ago was this notion of the killer app. That almost feels old-timey to say now, right? Back in when people really thought about cell phones as like a metaphor for where we want to go with robotics. We're going to have this killer app. We're going to do all this cool stuff. Well, that sort of is like sunsetted, right? I don't think we're necessarily worried about building an app, so to speak, right? But this notion of basically progressing along, building new applications, and then we got to the point where we took a lot of our scan and plan and basically turned it into a teaching repository. You'll notice it's called Workshop. And we grabbed the various pieces of it and we use it to teach people how to help themselves, right? So basically that led us to like, hey, instead of like just trying to make this app, right? The issue is once you go too far down your application space, well, anyone who wants to do anything that's slightly different, they got to do some unpacking. And that becomes inefficient. Whereas if we provide a set of tools and modules, that enables them to kind of build what they need, their specific application. So what does that look like, right? So we started thinking a little bit more about how we architect these solutions, right? So we started with our scan and plan at what the time was, so to speak, this notion of an app, and started breaking it into these capabilities, right? You'll notice here we have things like sensing, toolpath generation, and then of course there's actually some application stuff, right? Because in the end, your application's different than your application. It's different than your application back there, right? You're going to have specific code, configuration files that are unique to your application. But right, we can actually isolate that and make it in a way that you can add that in a less intrusive way without a bunch of like hardcore C++ work. And so that's actually led to this notion of basically creating a framework that's a little bit more modular, where we can have this information share and then think a little bit about providing tools to build out your application itself. That's a little bit more intuitive. So, we've basically have revised the architecture. The idea is to, if you want to do anything that's, so to speak, in the family of scan and plan, right? This idea of creating plugins. Like, oh, do you want to actually monitor? You've done the scan, you've done your planning, applied some toolpaths. You now want to run this process, but hey, you want to actually monitor your process. Well, you can just create a plugin and add what it is however you want to monitor. Are you monitoring force? Are you wanting to put a classifier that monitors the state of your paint as it's being applied? Well, that just becomes a plugin, right? The other thing that's been really interesting is like leveraging behavior tree in a slightly different context. Like we had a big debate yesterday, there was a couple conversations about state machines versus behavior trees. And there is a school out there that wants to make entire applications out of behavior trees, and you can do that, right? But obviously we've tried to be a little bit more prescriptive, right? So in the motion planning side of things, we already have a behavior tree style implementation called CPP task flow that enables you to customize and set up motion planning pipelines for your motion behavior. But we actually have created an implemented behavior tree, right? And that's an example here at the application level, right? So you can kind of keep your application level relatively finite. There's some configuration files. You can basically use it to set up and interact with your UI. Because if anyone who's deployed robots on the factory floor knows that the end user is going to have lots of opinions about the UI. So it's nice to be able to make changes to that without having to change a bunch of application code. That's where behavior tree makes a really nice difference. You can reconfigure your application behavior without doing a ton of hardcore C++ coding, right? And so again, this idea of modularity, the core modules all stay the same. So again, like, right, we're thinking a little bit about that developer experience because you're gonna iterate. By the time you start putting systems on the floor, we got one running in a foundry, grinding on some castings. Inevitably, they want to tweak some stuff. We're to the point now where that manufacturing engineer can make subtle changes to the behavior tree on their own. And they're not having to call us. And they're not touching any C++. That's really empowering, right? As that manufacturing engineering team wants to maybe replicate those systems in the future, right? It makes it like sort of speak less like, I need this robotics engineer, and a little bit more like, hey, manufacturing engineers can customize and optimize their application behavior as they see fit, right? So we've been actually trying to like add these sorts of tools to a couple of the other different modules to basically like harden, if you will, and set up basically in this refactor loop, right? We'll develop, distill, refactor to get to core modules that then we just stitch together with some application code. In this case, we used behavior tree. I talked a little bit about, some of you have asked me yesterday in particular about Tesseract. Why does Tesseract exist? Is it a thing? As we look to refactor some of the add clarity to the ROS Industrial open source project at rosindustrial.org, we'll try to be a little more explicit about what is in scope in the ROS Industrial open source project. Tesseract is a byproduct of the ROS Industrial open source project. It is, so to speak, an alternative to MoveIt, but not by no means a replacement for MoveIt. It actually excels in doing continuous motion processing, handling dynamic, or let's just say I want to add dynamically collision objects to my scene, or treat another manipulator as a collision object dynamically as should it enter the scene. That's where Tesseract excels, as well as in creating really interesting motion planning pipelines, where we know how to do something like trajectory splicing or some other high rate change in behavior of my motion planning performance. That's where Tesseract excels. This is just an example on the right. I know you can't see it, but again, it looks sort of behavior tree-ish like. That's intentional. That is what we've implemented for tuning motion planning pipelines using what is called CPP task flow. And that's already part of Tesseract. Obviously, we've been doing a lot of work on toolpath planning. For some of you who attended ROSCON, you may have attended the toolpath planning workshop led by our tech lead, Michael Ripperger. He was actually here last year and put on a master class as well. Actually, I think it was on motion planning tuning. But here we've done a lot of work in the last year on the module around toolpath planning, where we're doing a lot of different things around mesh modification, segmentation of submeshes. And here you can see we have a UI that's connected via behavior tree to the toolpath planning framework. And you can see here as people are making adjustments and doing submeshes, and you can actually then add a plugin to generate your submesh via a classifier. Again, it's just another module, right? You just use it as a plugin, create a behavior tree to call it, and it's in here. But in this particular example, you can see the person is manually selecting it. That's been a really, really useful tool. The behavior tree enables you to actually add that application code and tie it into your UI. Well, the other big thing we've done a lot of work on, again, to create a module that you can call in your application is calibration. This is actually largely extrinsic calibration primarily. We do offer utilities for intrinsic calibration, but we find once you get a system out in the wild, inevitably you bump something, right? We've got to run a calibration routine. It's really handy to have basically a utility that you can call. You throw the target out in your cell, you run a script or call a routine, and you can run your extrinsic calibration, do all the updates, and you're back up and running. So it's github.com, ROS-Industrial, industrial calibration. Included the URL. I borrowed this slide from Michael, full credit. But this is a really powerful tool. It's something we include in all of our deployments, and now being able to pull it in as a plugin or just use some simple behavior tree to pull it in when you need to based on something that's going on in your system is really powerful. So there's been a lot of enhancements here and some really nice ways to add customizability through the interface. So we hope the community feels that's useful. One of the other things that we've been working on, this came out of a bunch of feedback from the consortium in the Americas. Manufacturing engineers in particular were very interested in not having to leave the CAD environment to set up systems. So you can imagine you're at a big factory, you already have some industrial robotic equipment, you're interested in basically adding an industrial PC and a camera and turning it into a ROS-based system, add some ROS functionality to add a little bit of capability to an existing system. Sword is a plug-in to FreeCAD. We provide for free a trial version of it. You can create URDFs, you can create collision geometry, and you can do all the motion planning, tuning, and optimization right in FreeCAD. So after that, though, if you want, say, a full seat, there is a nominal fee. Because it's ease of use code, we do need to maintain it for Linux and Windows. But it's pretty low cost. But trials are available. If you are comfortable with FreeCAD and curious about Sword and playing around with some of the motion planning, tuning, and Tesseract, this is sometimes a really handy tool and it really streamlines the URDF creation process as well. One of the other things we've been doing a lot of work on is providing containers. And obviously we've spent the last 2 years really working hard on America's supported content to get CI going. But this notion of layering containers also is really nice. And so you'll see more and more basically standard architectures for how we can basically add your application level code. That's kind of what you see on top, right? That's what I talked a little bit more about, the modular application code. And then you have this stack and you can containerize the whole thing. So we've been supporting and providing a lot of examples to that. We recently completed an FTP. A lot of these enhancements I've talked about were born out of this Focus Technical project. For those who may not recall, Focus Technical projects where members get together and can work on some foundational capabilities. Here we are working with about 5 members, including another consortium, to implement the Foundry capability in a Foundry and making a ROS-based system that was replicated at a university. So as grad students develop new functionalities, they can create plugins that go right into the Foundry that's like 3 states over. So it's a really neat project, a really neat example. But as far as what we're trying to do, that wraps up the FTP, but what we got going on next is this continuing push and helping out OEMs, right? So I was really excited to hear the work that was coming out of Mitsubishi Electric. Congratulations, guys. We'd like to keep what we can do to emulate that model across our network. Sorry about the video, it's a little jerky. But documentation enhancements, we're continually trying to improve the documentation, provide these examples around Docker, provide how we're using behavior tree, this notion of building application code and leveraging modularity, and of course, additional guidance for leverage of ROS-II. We've got some work to do to sort of clean up things and make it a little bit more navigable for people who stumble across rosindustrial.org and can't quite make heads or tails about like it's tied to ROS-II. So we have been efforting that across our regions, and we have beginnings of a new draft website. We look forward to kind of continuing work on that and continuing supporting each other in more unified training resources. If you have questions about getting exposed to some of the training content you hear is going on in the Americas, just let us know. You can work through Maria. If you're based in Europe, you can work through Vishnu. We're happy to help. The content and the resources are out there, right? So stay tuned. There's going to be a number of different workshops. As I said, the recent workshop on toolpath planning, we're going to try to make some more content of that out there and accessible. So if you couldn't make ROSCON and you're curious about toolpath planning, that's out there. We're excited to work with the AP region here on ROSCON 25, so stay tuned for announcements around that. We will likely, if there are masterclass opportunities, seek to get involved with that in conjunction with ROSCON. Our meeting, this event for Americas, will be May 2025 on May 15th, co-located with Automate, which is the America's largest conference around automation and robotics. So stay tuned. We'll have information up on rosindustrial.org. We're happy to welcome anyone from here in this region. If they want to come over, attend the conference, and crash our meeting, we're always welcome to have a bigger set of voices come and provide feedback on what we're working on. Anyways, but hey, there's a lot of great tools out there. We don't know if they're aligned with what you need unless you poke at them, submit issues, complain. Collaboration is the best way to make things better. So thank you for the opportunity to come here today. Feel free to check out all the resources. I'm here the rest of the day. Ask me questions. Thanks again, and continue to have a great day today. Thanks.